Hey guys, it's Mr. H, Chapter 1, Lesson 5, Classify Rational Numbers. This is the type of lesson that requires a lot of focus, a lot of listening. You know what you can do also? Take out another piece of paper and copy the notes as I go. What I write, you write. I know maybe you already did this in class, but it won't hurt to rewrite them again. You might learn something new. All right. Rational numbers. You have to know what a rational number is. And a rational number is any number that can be expressed as a fraction or a decimal. Now think about that. That's pretty much every single number. You can write any number as a fraction, even a whole number. Yes, even a whole number can be written as a fraction and as a decimal. This is a quick little mini lesson within a lesson. Okay, I'm going to talk about terminating decimals and repeating decimal. Terminating decimal means the decimal stops. It doesn't keep going. So like 25 hundredths, that comes from the fraction 1/4. 25 hundredths stops. You don't have any numbers repeating themselves. It doesn't say 0.25555. See what I'm saying? It just stops. And then a repeating decimal, something like 0.33333, which can be represented as the fraction 1/3. That's just an extra little info, and it's something you should know. I made a mistake there. I think I put 2/5, but it's not 2/5, it's 1/4. Like I said, it's okay to make mistakes as long as you know where you made the mistake and how to fix your mistake. Alright, so back to the repeating decimal. When it's a repeating decimal, you want to use bar notation because you don't want to write 1/3 as a decimal as 0.333333. You don't want to do that, right? And using bar notation simply means that whatever number you put that bar above, it means that that number keeps repeating itself. So if you see a bar on top of a number, just remember that bar represents that digit in the number keeps repeating itself. That is a repeating decimal. Terminating decimals, you've seen those before. Probably the new thing you haven't heard of is the repeating decimal. And big hint right here, huge key, major key alert. Every number is a rational number. Now that's kind of like a tricky sentence to understand. But whatever number you can think of, it's a rational number. But that does not mean that every rational number can be an integer or a whole number. Hopefully that sentence that I just said didn't confuse you, but it should make sense here in a little bit. So I drew a huge square because rational numbers are every number. And then I drew integers within the square of rational numbers, and then within the integer circle I drew whole numbers, a whole number circle. And I already put some whole numbers in there like 8, 1, 13. Now, do you remember what integers are? They are whole numbers, right? And they're opposites. Make sure to include 0. So, the opposite of an 8 is a negative 8. A negative 8 is not a whole number, but it is an integer and it is a rational number. A positive 1 is a whole number, it is an integer, and it is a rational number. You following me here? A negative 1 is an integer, but it's not a whole number, but it is a rational number, because any number or every number is a rational number. Now here I'm writing numbers that are only rational numbers. So I want you to pause the video here, pause it right now, and try to look at what makes an integer an integer, what makes a rational number, what makes a whole number a whole number. Hopefully you can spot the difference. You see the rational numbers, they all have decimals and they all have fractions. You don't see those in the integer section, do you? You don't see those in the whole number section, do you? Nope, you don't. Because a rational number is like 8/10, 1/2, 5 and 33/100, -1 and 4/10, -5 and 12/100. Alright, let's do some examples. When I get to the examples part, guys, I need you to pause the video, okay, before I solve it. So here you have a -14. What I want you to do here is I want you to classify this number. So pause the video right now and try classifying this number as a whole number, an integer, or a rational number. Alright, I already put it in the integer section. So a -14 is an integer, and it's also a rational number. I almost put a whole number. Jeez Louise. It's not a whole number, guys, because it's not positive. So a -14 is just an integer and a rational number. Pause right here. Pause the video right here and try to classify this one. That's 25ths. I know, immediately looking at it, you want to immediately say it's a rational number, and guess what? Every number is a rational number. But this one's tricky because it's an improper fraction. So anytime you have an improper fraction, what I want you to do is simplify it, divide it. Because it might give you a number that's not a decimal. So 20 divided by 5 gives you 4. Now, you got to remember too that a fraction is a division problem, right? So 20 divided by 5 equals 4. And if it equals 4, that means that 25ths, which equals 4, is actually a whole number, an integer, and a rational number. That's a major key right there, guys. Anytime you see an improper fraction, make sure you divide it to be able to classify it correctly. Study, study, study. Stay sharp. Watch my videos. You got this. I believe in you. See you next time.